The next thing we're going to work on is making an assembly in SolidWorks. And so I'm going to have you make some parts, just like usual. I have a tab that has a bunch of parts for you to make. And so we're going to go into new and pick an assembly. So just double click on it or click assembly and click OK, it doesn't matter. And so if you have any files open, so like I already have this other assembly I'm working on open, it has it here, I can pick it and try and bring it in. If you don't have anything open, and you do that, it'll automatically open up a new file. So if I just close that one, so I say new assembly. If I don't have anything open, it's going to ask me, hey, what parts do you want to put into this? If you have all of your parts already open in SolidWorks, they're going to be filled out in this open documents list, and you just pick which ones you want. So it kind of works both ways. If you have them open, it's a little easier, but I like to have one file open at a time, especially if you're at home and maybe your computer's not the best. If you have less stuff open, it works better.
SolidWorks, we can go into the file, pick it like from Fusion or Mac.
Yeah, so from here, you can use all of these different formats. So we can't read a Fusion file directly, but from Fusion you can export as a step and then bring that in. But I'm going to bring in this box, say open, and I can kind of drag it around on the screen. But if I just hit enter, it's going to put it back with the origin from the part, placed at the origin of the assembly. So it's there, and you can see there's a little F next to it. That means it's fixed. In SolidWorks, it's not called grounded, it's called fixed or floating. Both have F as a prefix, but if you float it, then it has a negative sign there telling you that it's not stuck. So I'm going to fix it. There we go. So that one's fixed. Now I want to add another part. I'm going to go to insert component, bring in this little tab that you're going to make. And I'm just going to click anywhere to set it down. I'm going to hit it again, grab this bushing, set it down there. Okay? So when we go to start putting our stuff together, we don't just do one joint like we do in Fusion. You have to pick multiple things. And so you can align by faces, by axes, by edges, by points, and put those things together. So if you pick mate, and I'm going to pick this face here, so that's kind of the order of importance. Faces, then axes, then edges, then points. So I pick this face here, and I spin around and grab the back of this part. You can see it slides it over. Because I have these options to do. So I can make it coincident. So coincident means it's going to touch each other, right? I can make it parallel, where now they're parallel, but they're not touching. But they have to stay parallel. I can make them perpendicular. So now they're going to be perpendicular to each other. Or I can make it a set distance. So now I can say I want them parallel, but this far apart. Or I can tell it I want it to be at a certain angle to each other. And I can also control if they're facing each other or facing the same direction. So on this one, I want it to face the same direction, or face each other. And I want it to be coincident, because that's going to get bolted to it. So I'm going to say OK. For this one, though, I'm going to pick the top. And you notice when I hit OK, it kept me in the mate command. So it knows you're going to put stuff in, and you're going to want to put them together, and it knows you have to use more than one. So I pick that. Oop, nope, I don't want that edge. Delete that. I want that face, because I want those faces to be lined up with each other. But I need to flip it. So I hit the flip button, and it turns it over. So now I can say OK. Also, when I put these holes together here, when I put this together, I'm going to use those holes to line it up. There's two ways we can do it. One is we can line this hole with there and this hole with here. That's great if those holes are perfect. But sometimes it maybe instead of a hole, you have a slot, or you've messed up your model and they're off by a tiny bit, you should fix that. But maybe your parts are off just a little bit on purpose. And because maybe you've got a bigger clearance hole here and you need to kind of adjust it, or maybe the measurement from the side is going to be a little wonky or whatever, but you've got clearance to make it work. And so it's usually better to pick and kind of how you want them to be aligned. So I just want those two to be parallel to each other in the end. That way I don't have to put one axis instead of having to put two axes, right? So kind of the order of preference: faces, axis. If I know I want this thing to be straight across, I'm gonna use two different plane things to line it up, and then only one axis to line it up. So now I can say okay on that one. And so if I grab it and move it, you can see it's moving along that plane.
You're like basically just in more.
Oh, I drug it far away.
Hey, that
So I'm just gonna go back to undo. Back here. And this one, same thing. It can move, but it's gonna be staying on that face. So that's the planes. So now I need to line up the axes. I'm gonna pick the cylinder and that cylinder. And it's gonna go there. I'm gonna say okay. And I want that cylinder to go to that cylinder. I'm gonna say okay. Then I can hit escape. And uh-oh. Maybe I didn't hit okay on that parallel.
Well, you didn't select those two.
Oh, nope, see, I didn't okay the parallel. So I'm gonna go ahead and mate, pick those two tops, parallel. And now, so yeah, I had them selected and I think I hit escape. But now this thing doesn't move. This thing here can still spin. You can't see it, but it's spinning. If I had a single cut on it, you'd see it. But in reality, if you don't add a mate to something, then it can move in the other direction. So by not adding something lining that up, so now it can rotate. It doesn't really matter if this can rotate or not. It's symmetrical, it's round, doesn't matter. Yeah. So that's mating to faces, mating by axis. If I have, throw in another one of these. Just if I do the mate first and I do axis to axis, I can still use this to flip direction. Okay? So, but I usually like to line up things that are maybe flat against each other first. That's usually my first step. Things that are going to be touching, going to be my first joint, and then after that. Over here, you can see that the tab doesn't have the minus sign anymore. That means it's fully constrained. The bushing, though, has the minus because it can rotate. You can see when I go over it, the bounding box rotates a little bit. If I grab it, move it a little bit, you can see the bounding box kind of rotates again. So I can do that to make faces, axes. Those are the two that you're going to use 99% of the time. Okay? Edges are used a little bit less commonly, or a lot less commonly. The main reason I use edges is for things like this, where I have a little triangle piece here, and I'm going to make a pyramid. So I'm going to insert another triangle that's not the same size, and I'm going to just copy it, paste it, paste it. Just wherever I have my mouse and I hit paste, it goes right there and I don't even have to click. But I only want 3 of those. So I'm going to make a little pyramid out of this. So I'm going to go into mate. I'm going to pick the edge and the edge. And then the edge and the edge. And the edge and the edge. Uh-oh. Flip it. Okay, now I can pick edge and the edge. And I want to go opposite. And then this edge goes to this edge. And so, because on an edge, you can see that it can slide back and forth and rotate around that edge. So it doesn't, when you do faces, that face is basically stuck there, can't rotate up and down, or kind of stops rotation in two directions. But you can slide in two directions and rotate in one. On an edge, kind of the opposite. I'm going to just undo, or just add one of those back in, just so you can see what happens. If I do a mate with an edge and a face. You can see you can kind of slide along the face, and it can rotate. And basically all it does is make sure that that edge stays on the face, but it can still rotate and slide and all this other stuff. And so it's not used as often, but one common kind of another, besides just edge-to-edge stuff like this, is if I want, like, I want this to be aligned with that and flipped. But now I want this edge to line up with where that face is. That. Yeah, I can do a mate between the face and the edge. Now the face will stay on that edge. So now it can only slide back and forth. So if I don't have like an edge there because I can't do faces because I don't have another face to line it up with, I can just pick that edge. Or I could have picked, see what happens if I pick the corner instead. So instead of doing the edge, if I edit that, but instead of doing the edge, I pick the corner. Now it can rotate and spin around that. So it's just making that corner stay on it, not the edge. The edge is making 2 points stay on that face, so it locks rotation. But if I only have 1 point now, it can still spin around that thing. So kind of like the pin and slot constraint or joint in Fusion, right? If I did just a linear constraint or an axis constraint, so let's say on this one, throw in another one of these tabs, and I did a joint between just these two, it can come and spin and slide. That's like the cylindrical joint in Fusion, right? So you can see how they kind of relate to each other just based on which ones you pick. It kind of has those same things. Same thing as if I had picked the tops there, and then sides here. Now it's a slider joint, basically, right? I haven't controlled the distance there, but it can slide back and forth. And whether I pick the side there or if I picked just this side to be parallel with that side, right? It would allow me to slide, but because I'm not giving it a set distance. So those are the mates that we have in SolidWorks. Any questions on those? And so what's the first mate or the first type of thing you should pick when you're doing a mate? Like if you're trying, yeah, faces. So if you can pick a face, pick a face. If you can pick two faces, they're gonna go together. That's gonna be easy. Kind of a lot of parts are either three faces or two faces and an axis. Or one face and an axis if it's just a round piece. If you can't do faces, pick axis. And then can't do those, or you need something that you can't do with a face with two faces, then do a face and an edge. If you're getting into something like the triangle thing, where you need just to touch the corners. There's no faces lining up with each other. Then do edges. Then do 2 edges. The time for like a single point would be like a ball joint. You want to have this be able to be in here and rotate in all directions. So I can make a ball joint, just a point there, a point to a point. So it's fixed in position, but it can rotate in all 3 directions. So that would be, so you can just pick like the sphere. Now pick the center of the sphere, and you can pick the cutout sphere, whatever. And so that's kind of the last one to do. So don't go and just pick a corner or something first. Because if you just pick corners of things to try and do joints, you're going to do like 50 of them for one thing. Or probably not 50, but maybe like 6. So we want, so that's doing that.